Hello guys. My name is Johnny Libertad, or you can translate it into Czech. My real name is this, but I translated it into English and Spanish. Uh, yeah. I will apply category theory on Python AI code here in this lecture. I'm from this city, from Czech Republic. We have year 2020. So yeah, we can start with this lecture. So there is content. So yeah, in this functor I have this content, and that content is uh, like motivation, some motivation, the age of AI, like emotional motivation, Wittgenstein, logical motivation, inspiration, why to apply category theory on AI code, AI Python code. Yeah. So we will be building our ladder. We will be building it through applying category theory on AI math, then applying category theory on Python code, and then applying category theory on AI Python code. And then I will finish this content of that functor, because we can understand these points like functor, origi, and some content within that functor. So then we will watch transcendence, like just motivation to do more AI. So yeah, another slide is a slide with a guy with ALS, Tim Shaw. So yeah, this is really inspiring story to program more AI, guys. So yeah.
If someone else does not enough. And my personal plan is to sort as many presents as I have for him. Even if that means I will use my last breath of words.
So this is Tim. That was applied AI. Really interesting story, and there are much more stories here on this channel, like the Age of AI. So yeah, that's like emotional motivation, and now I will do like logical motivation, why to apply. That was emotional motivation, why to do AI, and now I will explain why to apply category theory on AI. So Wittgenstein, the limits of my language mean the limits of my world. So we will try to purify Python AI code by category theory. We will purify language, we will purify AI. So Python language. The work when we speak about Haskell is already done by other people. So yeah, we will try to purify Python, but not just Python, because Python was already purified, but Python AI code. So yeah, we will follow Wittgenstein thoughts, and not just Wittgenstein, but also for e.g. Bartosz Milewski thoughts about applying category theory into computer code, because we are like in software, we are like these old guides building cathedrals. So we are like them, without any proper knowledge of mathematics, without any ideation, the holistic image about computer code. So we are just doing trial and error in software a lot of times. So because of that, we will apply category theory. So category theory applied on AI math. So yeah, you can watch this video. And there is global view in neural networks for G here. You can see global view in neural networks. So if you want, you can watch this lecture, or you can see locally. The same is with physics. Really good explanation here. You can watch it. So yeah, that's applied category theory applied on AI math. So another resource is this monadic MDPs or backpropagation as functor. These monadic MDPs by David Spivak are interesting. Certainly, yeah. It's not like here applied on neural network. It's applied on MDPs. So it's a communication using category theory to explain communication between different MDPs, for example, low-level MDP and high-level MDP. And you can use like these true properties, or you can like use these three things: coarse graining, planar sample, and it will give you some category. In this case, the symmetric monoidal category. So that's interesting. You can rewrite this stuff into this box. So this box is more abstract. These are higher level MDPs. These are low level MDPs. So yeah, these are applications of category theory on AI math. So we are building our ladder. We will kick off this ladder after that, but we are building it. So category theory applied on Python code. So you can see these resources, but we will be interested in just about this resource, and I have also some code from Lex Friedman in other slides. But first thing, we will do this monads in MyPython. So really good video on YouTube. So there were problem with type error. It's just an interesting example. It's probably a little bit harder, but yeah, it is not something like extremely hard. It's just a quick maybe. It's not like some deeper natural transformation. It's just like this. The guy, there are two operations like division and square root. And when you are dividing something by 0, for example 100 by 0, you will get none, and then type error. But we can use category theory in our thinking to compose this stuff, and now you are without type error. So yeah, you can watch this video, interesting video, understand these methods or functions. I'm from Java also. Java was my first programming language, so I say methods. So these functions, and here, and the important thing is that you will, when you will be dividing properly and square rooting properly, so you will get just, and if you will be dividing by 0, so you will get nothing. So that's maybe... You can read that code if you want. It is explained by this guy on that YouTube video. Yeah, other possible monads. So this, most interesting for me, it's this object relationship mappings from Django, because I was programming that big of time. It's really good object relationship mapping within Django, I think. So yeah, that's first example of applying category theory on Python, and now we will apply category theory on another example. It's like video by Lex Friedman, best feature of Python, list comprehensions. So we will apply this structure from this lecture by Bartosz Milewski. I don't say Bartosz Milewski because I'm Czech, so I can say it probably properly, Bartosz Milewski. So yeah, we will apply this composition of two functors, maybe list, that's functor, composition of maybe functor, and the list functor. So yeah, we will apply it on Lex code. Your module is bad here, or list is empty. The thing is that we have like maybe here, and we can have nothing or just XS. Sorry for the pronunciation, I'm Czech. So yeah. The thing is that we have here some code, some list. So yeah, we can like multiply these numbers and get these numbers. And then we can use filter, modulo, and we will get just these numbers. That's easy code. The thing is that maybe we can see maybe and list in that composition. For e.g., imagine that you will use that this list will be full of just 1 and 3s, so this list will be empty, because if you will modulo this 1 and this 9, so you will get nothing. So that's empty list, that's this, nothing. And if you will use some filter here, for e.g., yeah, some filter, like this, you will get just XS. So yeah, that can be like maybe list functor. The composition of maybe and list functor. But I'm not sure, it's just like I'm playing with that. Maybe it works, maybe it will not work. I'm not like category theorist, I'm just category theorist. So yeah, this is just another example of how you can play with these lists. Lex, I think Lex said it's a better example how to play with lists, but for me it's easier to apply this category theory on this stuff. So yay! Next chapter. Yeah, finally, applying category theory on AI Python code. In this chapter, I will just fly over Python AI code and see category theory structures in it. So yeah, reinforcement learning tutorial, deep reinforcement tutorial. So you can go to PyTorch and see that example. You can study what is forward. Yeah, this is like from this guy. My solutions to Bartosz-Milewski category theory for programmers. So from this guy, I'm using either structure and that composition structure that I will show. So yay. Reinforcement learning DQ tutorial. So implement the composition function in your favorite language. It takes two functions as arguments and returns a function that is their composition. So yeah, you can like go into this example and see compositions here of that badge norm or convolutional layer. Really, you can see these compositions within that AI code. So that's good. Realize that's composition. Yeah, these are just that you can see it probably in these graph neural networks, but I was unable to find, they didn't publish code, so I was trying to find something interesting from categorical point of view in this code, but I did not find anything interesting in that code. But I'm learning, and that's good. So I'm just building my ladder, and I will kick it off someday. But I'm just building the intuition here. So yeah, another example, Kaggle, another COVID example, but not drug discovery. But this is like COVID predictions. It's not COVID drug discovery, but COVID predictions. Yeah, the thing is that I tried to find some categorical structure within it, and I found either. The either type represents values with two possibilities. A value of type either, A, B is either left A or right B. So yeah, the thing is that you can visit this code, this website, and for e.g. here you can see if else statement, and you can see it like either A or B. You can use Curie-Howard-Lambek isomorphism. With either, there is always problems. So I'm not sure about this application, but if you will imagine that this is not empty, it has some data in it, so you can like really think it's either A or B. So, but with either we have problems. Yeah. So, by the way, Wittgenstein, he studied logics, so he applied category theory on language, because like if you say that Curie-Howard-Lambek isomorphism is walk-in, so Wittgenstein he applied category theory on language. Yeah, if you will transform logics into category theory, and you can transform it probably by Curie-Howard-Lambek isomorphism. Yeah. So we are just building our intuition. So that's everything, and in another video I will do some more interesting examples of applying category theory in AI Python code to see that code more properly. So this is the end of this chapter. We should do it more. It was fun, I think. Write a comment, like it or dislike it. Read more Wittgenstein. Yeah, really smart guy, this guy. He applied category theory. He applied logics, but yeah, because of that Curie-Howard-Lambek isomorphism, he applied category theory. And yeah. The limits of my language mean the limits of my world. So we expanded in this lecture our language, and in other lectures I will expand it more. Try to find more interesting category theory within Python AI code. So it was fun, guys. And something interesting about that Wittgenstein, yeah, that we can be like in present moment without time, without space. It's nice to meditate a little bit. That's like some thought by Wittgenstein. It was like a little bit spiritual, or a lot of spiritual, I don't know. So yeah, maybe I will do some lecture on Wittgenstein only. But yeah, thank you for your attention, and bye.
Water so pure, you can drink out of any river. This is your dream.
Not merely to cure disease, but to heal the planet and build a better future for all of us.